Hello. Today's video is about how to test a valve which has a top cap, and on my AVO valve meter Mark 4, and some have requested what the settings, how to do, and because it can be quite confusing to set it up on the Mark 4. So I'll go through a few steps. First of all, there are a couple of things that you need to do before we set the valves or test the valves. Is that the very first thing we need to do is to calibrate and set up the meter, configured it to the correct valve, and that is done using I've got a printout of the valve data sheet here, and using that. And today we're going to test valve which I got. It's a new old stock. It's a Philip valve EL360, which has a anode coupling on top with the top cap. And these are very old. This is probably 1950s or 60s or even earlier, and it's made in Great Britain. It's one of those valves I found in a lot stock. And it should be a brand new valve. It should give us readings as good as new, although it's very old. Let's go ahead and try it. Now, very first thing that we need to do is to find the EL360, which is here, and we're going to set up the valve parameters in the machine or the tester according to what is written in the book. So, as I said, the very first thing we need to do is a calibration and setting up the wheels and stuff for the correct pin numbers for the valve. But before we do that, I want to tell you that what I have done is, because we have to set up screen voltages, anode voltages, grid volts, and also the element, like heat element voltages and stuff like that, we're going to set this up in a way. I have made it easier by setting up, putting numbers according to what is in the reference book, going from left to right. So what I've done is, this is the Mark IV chart. So first of all, what we're going to do is to set up the top cap, sorry, not the top cap, the calibration for the valve for the correct number, which is done through the top here. Right, in this case it's 02 for the EL360, it's 020540310. That is number one. And then number two is check whether there's a top cap, and this one has A1. And there is a little plate here which you can put the top cap lead into it, and you put that into the A1 socket, right? So make sure that the valve meter is off, right, before we do anything. And one of the things that we need to also make sure that we do is to have the leakage test into the sine wave here, and this one into the circuit selector to cold check. Even if you accidentally put it on, that means these connections are not energized. Warning is that this is not a toy. This is a valve tester, and there is high voltage coming onto the anode and the cathode and all that type of stuff, and it is quite open. Although the valve tester itself does not work at the correct operating temperature or the correct parameters of the real valve when it is working in the circuits, it still is lethal voltage. So once it is on, you do not touch any of these wires or any of the connections here. So the very first thing we're going to do is making sure that this is on off, and then I've set off the valve parameters for that socket, 020540310, and A1 on the top cap, which is that one there. And then we're going to set up, that is number two. That is, then the next one is number three, is the heater voltage. So I've numbered them, like 1, 2, 3 is the heater voltage. Next would be the grid voltage number 4, then anode voltage 5, screen voltage 6, and then the milliampere settings for the meter. Normally I keep it at 100 because that'll give the full deflection. That's number 7, and the 8 is the milliampere voltage measurement, and that's where we measure the accuracy of the valve as well, and transconductance, I would say, right? So that's the normal procedure. And this set is to calibrate the meter to make sure it is on 0 volts when we start, which I will show you how to do. These two will be on 0. This is your sort of backing off for the meter, which I will show you later. And this is the selector for your anode or cathode, what you're testing, anode 1, anode 2, and the screen. Normally keep it on A1 because this has only one, and this has to be on, as I said, on the mark, the sine wave mark, and this on close check. Now, so the voltage for the element, heat element, is 6.3. So I'm going to set it to 6.3. This knob is in the increment of 10, so this has to be 0 because this one is between 0 to 7.5 volts. So I would be setting this one up to 6.3 because of the valve for EL, the heat element for the voltage for heat element is 6.3. Then we move to number 4, right? So this is number 3. Number 4 in the chart is your grid volts. So that's 7.7. So this has a scale of 0 to 10, sorry, 0 to 5 and 0 to 5 plus 5. So this is on the plus 5 scale, so already 5 is there, so we just need to make sure it's 2.7. so that's 2.7 there, if I'm not mistaken. 1, 2, yeah, 2.7 grid volts, sorry, 7.5, so 5 plus 2.5 or 2.7. And then the next one is your anode voltage, which is 100 volts, and just click up to 100 here. And screen voltage also is 100, and we have to measure on the scale of 100. It should have, when the valve is good, it should show milliamperes on the current range as 100. So I will set this on up to 100 here, which is already done. Right now, basically I'm going to enter the valve into this socket, which is the AO8, like that, and the top cap goes on here. Now this is very, very important with using top caps. High voltage, not to touch any of these lines once it's working, right? I'm going to double check I've already set the wheels for the correct heater and anode settings here. So it's 0 to 0, 540, 310 for the EL360. Right, and the last one would be your number 8 is your milliampere voltage. What we need to check is the milliamps, so it has to be 14, and that's on a 1 to 60 scale, which is here. The outer scale is 60, 0 to 60, and I'm setting it at 14. Right, yeah, 14, so which is 15, one notch below 15. Now the tester is configured to go ahead with the test, right? We can go ahead by making sure that, again, these are on the cold check. This is 100, and that's on the last one. So First of all, what we do is we power it on, and the meter will deflect, and this calibrates the meter to the line voltage. So the meter has to come to where it says the black line just above the 90 milliampere ohm range. There is a little black mark where it says short. There's a little black mark where you need to center the meter as best as you can, and in my case that is probably the best I'm going to get. Right, so that's right on top. Right, now what we're going to do is test it for leakage between the heat element, cathode, screen, grid, all that type of stuff. The heater, at this stage, there is no power on the meter, on the tester, or at least to the tube. Right, so these are all numb. And first of all, we switch on to the heater to see if it is shorting, and it is saying it is short. If there is a short, the needle will, deflect here. The heater is a short because the heater is between the two elements, it's connected. So it should be that. If it is in the heater position, if that's zeroed, that means the heater is burnt, it's not working. So that is a good sign, but from there on, there should be no deflection. This has to be on the left-hand side. As you can see now, the meter will, as soon as I put it to cathode, the meter will deflect to the left. So this basically is, there's no connectivity there, there's no shorts on the grid, there's no short on the screen, there's no short on the anodes, and so on and so forth. It's zeroed, right? Which also shows that the correct wheel settings are set for the correct valve, right? We put it back here. Now we can begin the first process of testing the valve. We're going to put it into the heater check, which means we're actually going to energize. That 6.3 is going to go into that heater element there, and you will start to see the so the elements firing up. You can see it glowing inside now. I don't know whether you can see it, but you can't see it, but anyway, it is red. It is very red, and it is glowing, right? So that means it is getting energized. The heater is getting power. We give it about a minute or so to heat up, as you know, with valves, and then we can, the next check is the CH, that is cathode to heater insulation. So you got the anode, then the screen, and the cathode. So basically there should be nothing, and in between the heater, heater should not be touching any of these physically. So also, if it's too close, there'll be issues as well. So we're going to put it there, and if there was a short, this would deflect, and it also measures the mega ohm, on the mega ohm scale, how much there is. So this is well over 25 mega ohms. There's slightly an error in this meter as well. It should be in the zero position. And now, since there's nothing there, we could go into the test mode. Test mode means we're actually testing the valve now. So now everything is clear. These are on hundreds. This is on 7.7, and right, yeah, 7.7. Sorry, I've got the wrong setting. 7.5 and 2. Yeah, that's where I should be. So basically we are good to go ahead for the test. When we go for the test and the meter has deflected above, I'm just going to double check. Yeah. So the meter has deflected into the 100. I've just switched off. It's going back into 100 as the tube gets warmed up. So that's what is expected of this valve, which is basically on that scale it should read 100 if it is a good one, and as you can see it's reading 100. Perfect. Now you can also do a test called transconductance test for to see if the meter is the valve is performing good. And for that, what we need to do is we keep the current, same current, 14 volts going into the valve, and same voltage going to the valve, and the current is set as 14. We are going to do what is known as back off the meter. So the current will be the same, but the meter is, we're going to physically move the meter there and add 1 millivolt in 1 volt into the tube, which will show up in here when we will show you how to do that. So this is coarse and this is fine. We're going to move the meter backwards, and you have to be gentle because these meters are very hard to find if you want to replace them. So, and then we're going to go into a finer scale here from 100 to maybe 25. Bring it to 0. We're trying to bring the meter to 0. Don't go straight to 25, 2.5. So that's 0. Now the meter is in 0. We've added extra a volt. There, it's slowly deflecting, and we are going to, sorry, we've been now going to add that 1 volt and see if that meter needle goes up to the good mark. And there's a mark here in the green line says good, and it has deflected there. So that means the meter is working and the valve is very good. It's 100%. There's no dramas. If for example, if the meter was, you know, further down, we could increase or decrease the milliampere per voltage and see what the deflection is and see what percentage of the valve is performing, like whether it's 90% or 80% or 50%. We could do that. But this valve is, as you know, it's a very, very good brand new valve. It's been sitting in the box for a long time. So that's an EL360 being tested. Yeah, that's pretty much it. And final test would be the gas leakage test. By now, if there's a leakage, we would have known. But anyway, the leakage test shows that, you know, it goes back to 0. There is no leakage, gas leakage. So test is pretty much complete. So we can shut down by putting all these 0, and then we can put these 1 to 100 as well before we do the backing off the, yeah, that's it. Test is complete, and that's how you check a valve, especially one with a top cap, and it's an EL360. Thank you for watching.